So before we can begin, there's in your textbook there is a corollary, which is like a theorem or part of a theorem. And basically it just goes like this. If f prime of x is equal to g prime of x, at each point of an interval capital I, then there a constant capital C such that f of x is equal to g of x plus c. And so this is what we need for example number 6. And so what they're saying is that I could take two functions, and when I differentiate them, it's going to have the same derivative. And so let me give you a practical example, and then we'll do example number 6. So consider f of x equals 3x squared, and g of x equals 3x squared plus 4. Okay, does that make sense? So now what this means, this is really, we're starting to set you up for integrals, okay, and anti-differentiation. And so we're doing it right now while we deal with the derivatives, so you get ready for it. But basically, when I take the derivative, what's the derivative of f prime?
6x.
6x, right? All right, what's the derivative of g prime?
6x.
Okay, that's really what that corollary is talking about. So when what we use this for in the real world is that when we take, sometimes we're given a derivative or a rate of change that's represented as a function, and what we need to do is work backwards. So what they're really trying to say is, and this is, I'm gonna teach a little bit ahead, so it makes a little more sense as opposed to what you're trying to do. If I take 6x, all right, and I graph that. Well, that's a linear function, but we learned yesterday that when the derivative is negative, what do we know about the regular function? It's decreasing. And when the derivative is positive, what do we know about the regular function? It's increasing. So this derivative represents the slope of the tangent line for all x. So now if I come back in here and I graph my original functions and I say 3 times x squared, right? And then the next one is 3 times x squared plus 4, and I graph those, that's my original function f of x. And then the plus 4 just shifts it up vertically 4 units. But guess what? The slope is actually the same. And what I mean by that is if I come in here and I hit second trace, and I want to find dy dx at a point, I'm going to choose my first function, the purple function. Now we know what the derivative is. If I choose x equals 1, what will be the slope at x equals 1? Well, we would plug it in. Yeah, it'd be 6. 6 times 1. So if I choose 1, now keep in mind this is on the purple line, my slope on the purple curve, which is g of x, is 6. Different point though, x equals 1, y equals 7, right? Now if I do that same thing again, But now I'm going to choose y sub 2, which is just vertically translated. Well, actually, that's the original one. The other one was vertically translated up for 4 units. And if I put in 1, it has the same derivative, which means I'll have the same slope at that point, but it's a different xy. So when we go to take antiderivatives, when we do the antiderivatives, we can't ignore the possibility that there might be a +4 or a -7 or a +3 tacked on to the antiderivative. And so that's what we're talking about today. So now how does this relate to example number 6 in our textbook? Or actually it doesn't, because I'm doing example number 7. Did I write down example 6?
No, you said corollary.
Oh. So, I'm sorry, it's actually example number 7 out of the textbook, and it says, find the function f of x, whose derivative, so we have to find that, but the derivative of this is sine of x. But it passes through the point 0, 2. So it passes through the point 0, 2. So now what this means is when we go to guess, we've got to think like this. Okay? We've got to think to ourselves, okay, f prime is sine of x. Now this is an easy one for us. We've got to think to ourselves, what function would have a derivative of sine of x? What do you think it is?
Cosine.
Well, what's the derivative of cosine though?
Negative sine.
Negative sine, so what should be up here?
Negative cosine.
Negative cosine. So it should be negative cosine, but what there's one other thing that I've got to tack on is that plus c. Does that make sense?
Yes. Yeah.
So now, how do I figure out what c is?
Put in the 0 and the 2 as x.
Yep, we're going to have to plug that in. So what I'm going to do is I have the point 0, 2, and this is my x and this is my y. And so I think that f of 0, which is equal to negative cosine of 0 plus c. Alright?
Yes.
But f of 0 is really 2, so I've got to think in terms of negative cosine of 0 plus c. So cosine of 0, cosine is the x value, 0 is the angle. So on my unit circle, we gotta do this in our head, right?
Oh.
So this is my unit circle here, where we have cosine of x, comma y, or not comma y. It's cosine, comma sine, right? That's how it is on the unit circle. And 0 degrees is the same as 0 radians, so that means this point here, which is 1, 1, comma 0. So what's cosine at 0? 1. So this becomes 2 equals negative 1 plus c. Add 1 to both sides, and I get c is equal to 3. I think. Let me double check my book. Yep. So my original function then should be f of x is equal to negative cosine of x plus 3. Congratulations, you just learned how to take the antiderivative of a function. Okay? Any questions on that? Okay. Oh, now I put that thing. thing down, which is gonna be a pain. Wait, I can do it up here.